Zan here, author of the sci-fi series The Chronicles of Deneb and your host of Chatting with AI. Today we're going to be diving into black holes. When we think of black holes, we tend to imagine solitary monsters, dark, silent, and hauntingly alone. But the universe doesn't always build its giants in isolation. Increasingly, astronomers are discovering that many of the most massive black holes didn't form in one dramatic collapse, but through partnership. This month, my AI co-hosts and I are exploring black hole pairing, how they find each other, spiral together, collide, and grow into something far larger than they could ever be alone. And yes, this is something I explore in the Chronicles of Deneb, but it turns out the real universe may be doing exactly the same thing. So chat, let's talk about binary black holes.
Well, Zan, a binary black hole is exactly what it sounds like. Two black holes locked in orbit around each other. This usually begins after massive stars die. When a giant star runs out of fuel, it collapses under its own gravity into a singularity, forming a black hole. In crowded regions of space, like dense star clusters or the centers of young galaxies, these black holes don't always drift away. Instead, gravity pulls them together. Once two black holes come close enough, they become bound. At first, the orbit is wide. The black holes may take thousands or even millions of years to complete a single loop around each other.
Two black holes circling each other in a slow gravitational dance, getting closer and closer together over eons. But that stability doesn't last, does it?
No, it does not. As they orbit each other, something extraordinary happens. They begin to lose energy, not through light, not through heat, but through gravitational waves. These are ripples in the fabric of space-time itself, first predicted by Einstein, and only directly detected in 2015. Every orbit sends out a faint tremor across the universe. And with each tremor, the orbit shrinks. The black holes spiral closer, faster, tighter. Eventually, the distance between them becomes so small that the system destabilizes.
I imagine that when they finally collide and merge, it must be one of the most violent events in existence.
Yes, indeed. For a brief moment, a single black hole merger can release more energy than the combined light of every star in the observable universe, briefly outshining entire galaxies, though invisible to our eyes. What remains is heavier, faster spinning, and far more powerful than either original black hole. And here's where things get really interesting. That new black hole doesn't have to stop growing. Astronomers now believe that many black holes are second generation, or even third generation, objects. In other words, they're made from earlier black holes' corpses from previous mergers. That new black hole can later pair up again, repeating the process.
When I think about this on a cosmic time scale, it raises a big question. How did supermassive black holes, that are billions of times the mass of our sun, form so early in the universe? And yet, they existed when our universe was still very young. Growing that large through feeding alone on gas and dust, it should not have been possible in that time frame.
Exactly. Mergers change the math, and pairing speeds everything up. We've discovered that black hole pairing doesn't just affect the black holes, but it shapes galaxies, star formation, and the large-scale structure of the universe itself. Every major merger releases gravitational waves that ripple across space-time, signals we're only just learning how to read. Each detection adds another piece to the story of how the universe builds complexity from collapse. This is not a universe of static objects. It's a universe of relationships.
In the Chronicles of Deneb, my character Tara Kabor, who is a professor of astrophysics, she explains black hole growth using this exact idea that black holes don't just feed, they pair. That concept was not invented out of thin air. It is grounded in real astrophysics and increasingly real observation. Science fiction often doesn't predict the future. It listens carefully to the present and follows the implications where they lead. Black holes may be the darkest objects in the universe, but their story is one of connection and of creation. And as we continue to listen to the universe through gravitational waves, we may discover that even in the deepest darkness, nothing truly forms alone. I'm Zan Raby, author of the sci-fi series The Chronicles of Deneb. Like, follow, and share if you laughed, learned, or are now slightly worried that the dust bunny under your bed might become a gravitational singularity in a couple of billion years. Till next time.